The year 1943 marked a turning point in the war, demanding a decisive response from the German armored forces. The Panther tank was conceived as the answer to the Soviet Tu-34, a machine that had profoundly shocked the Wehrmacht upon its initial encounter. German High Command saw the Panther not merely as an evolutionary improvement, but as a revolutionary return to armored dominance on the Eastern Front. Its thick, beautifully sloped frontal armor was a marvel of design, rendering it nearly impervious to almost all Allied anti-tank guns at typical engagement ranges. The main armament, the high-velocity 7.5 cm kilowatt K42LR70 cannon, possessed an unmatched lethality, capable of penetrating any enemy armor from distances exceeding a mile. This combination of protection and firepower immediately instilled a deep, perhaps overconfident, trust in the officers and tank crews who were slated to operate it. They believed they were receiving the finest battle tank in the world, a technological trump card that would reverse the grinding momentum of the Soviet advance. Initial training and testing, conducted on the firm ground of German ranges, only reinforced this powerful belief in the tank's superiority. The Panther's powerful Maybach engine provided a respectable top speed, further suggesting a highly mobile platform capable of executing classic blitzkrieg maneuvers. Officers confidently planned sweeping, deep penetration thrusts, assured that their new Steel Cat could withstand anything the Soviets could throw at it. This initial faith, however, was fundamentally based on the tank's specifications on paper, failing to account for the brutal reality of sustained combat operations. The inherent genius of the design blinded many to the crucial weaknesses woven into the machine by its rushed and desperate development cycle. This powerful sense of armored invincibility was a psychological shield for the German command, but it was a shield built on a foundation of operational uncertainty. The true test of the Panther was fast approaching, and the unforgiving battlefields of the East would soon reveal the chasm between expectation and performance. The development timeline for the Panther tank was brutally compressed, a necessary evil driven by the immediate threat posed by the Tu-34. Engineers at companies like MAN and Daimler-Benz raced against an impossible clock, sacrificing vital testing time for rapid mass production. Adolf Hitler himself constantly intervened in the design process, demanding an ever thicker armor and heavier main gun, increasing the tank's weight significantly. This political and military pressure led to a phenomenon known as over-engineering, where complexity was prioritized over maintainability and reliability. The innovative, complex transmission and the unique interleaved road wheel system were designed for optimal combat performance but were nightmares to manufacture and repair. Wartime resource shortages meant that quality control often suffered, leading to an inconsistent standard of components being installed across different production batches. Critical internal components, like the gears in the final drive, were rushed through production lines without the necessary hardening or meticulous tolerance checks. The engine compartment was often poorly insulated, leading to an alarming propensity for the early D models to catch fire during long, sustained road marches. This constant push for immediate deployment meant that many Panthers were rolling off the assembly line with known, uncorrected flaws. The engineers understood the risks, but the military imperative to get the new tank to the front lines overrode these vital concerns. A fundamental design oversight was the failure to properly scale the internal components to manage the tank's final, immense operational weight. What started as a design for a 35-ton medium tank was stretched to a 45-ton heavy-medium tank, placing impossible stresses on its internal mechanics. This internal conflict between design ambition and manufacturing reality was the true original sin of the Panther, a flaw that no amount of firepower could ever compensate for. The result was a beautiful, formidable machine that was inherently fragile, a legend that was flawed from the very first welded seam. The first major deployment of the Panther at the Battle of Kursk served as a shocking and immediate revelation of its profound mechanical shortcomings. Intended to spearhead the decisive German offensive, the Panther regiments instead collapsed under the strain of the long approach march before firing a single shot. Engine failures were rampant, caused by overheating and poor insulation in the early production models of the Maybach engine. The most common culprit, the final drive assembly, began to fail with alarming frequency, leaving dozens of tanks stranded along the dusty roads leading to the front. It is recorded that a staggering number of the initial 200 Panthers were non-operational due to mechanical breakdowns within the first 2 days of the operation. German officers watched in disbelief and frustration as their seemingly invincible tanks were consumed by internal combustion or simply immobilized by their own complex mechanics. The disastrous debut ensured that the full, concentrated force of the Panther was never brought to bear on the Soviet defenses as planned. This unexpected frailty severely limited the strategic flexibility of the German attack, forcing commanders to rely on older, less capable Panzer IVs and Tigers. The High Command's trust in the new weapon was catastrophically undermined by simple metal fatigue and poor engineering choices. Many of the immobilized tanks had to be recovered under fire, draining critical resources and diverting valuable recovery assets from other vital operations. The sight of a high-tech wonder weapon being towed from the battlefield without ever having engaged the enemy was a profound blow to the morale of the entire armored corps. Soviet intelligence quickly noticed the high rate of mechanical losses, realizing that often, patience was a better weapon against the Panther than a direct hit. Kursk proved definitively that a tank that cannot reliably drive into battle is merely a beautifully armored liability, regardless of its gun's power. The baptism of fire was a baptism of shame, instantly destroying the myth of the Panther's operational readiness for all who witnessed the catastrophe. The most significant and persistent mechanical failure of the Panther tank was centered in its poorly designed and undersized final drive unit. This component, which transfers power from the transmission to the tracks, was never structurally reinforced to handle the true operational weight of the heavy tank. Engineers were unable to correct this fundamental flaw without a complete, time-consuming redesign, which was impossible under the pressures of wartime production. The massive torque generated by the Maybach engine, especially when traversing rough terrain or attempting a sharp turn, constantly stressed the final drive gears past their breaking point. The result was an almost predictable failure, grinding gears, catastrophic internal shattering, and instant, complete immobilization of the tank. Final drive failure could occur after a mere few hundred kilometers of cross-country movement, often in the middle of an offensive maneuver. The repair process was a logistical nightmare that could not be undertaken in the field, requiring specialized tools and a massive amount of labor. To replace the final drive, the crew had to remove the large, heavy frontal armor plate and the entire assembly, a job that took days in a controlled depot environment. This meant that a single broken gear tooth could effectively remove 500,000 Reichsmarks war machine from combat for weeks or forever. The inability to quickly field repair this crucial component meant that Panthers with a busted final drive were routinely destroyed and abandoned during retreats. Tank commanders grew to dread the telltale grinding sound from the front of the hull more than the sound of incoming artillery shells. This single, structural flaw became the physical embodiment of the conflict between the tank's immense firepower and its shocking, underlying fragility. The German armored corps was essentially forced to field a world-class main gun platform that was crippled by an amateurish, poorly specified drive system. The Panther tank presented its officers with a deep, paralyzing dilemma that compromised the very tenets of German maneuver warfare. On one hand, they commanded a tank with a gun that could defeat the enemy from safety and armor that often made them immune to frontal return fire. This individual power allowed them to feel a momentary sense of invincible superiority in direct, head-to-head combat against the best Allied tanks. On the other hand, this feeling was constantly offset by the terrifying knowledge that any sudden acceleration or sharp turn could instantly destroy their vehicle's mobility. The fear of a transmission or final drive failure meant officers were forced to employ their tanks with a caution that was uncharacteristic of the bold blitzkrieg doctrine. They could not afford to execute the deep, fast, and sweeping flanking maneuvers that the Panther's speed was theoretically designed for. Instead, they often had to commit their tanks piecemeal, or keep them stationary, using them essentially as highly mobile, powerful anti-tank guns. This inherent lack of trust in the machine's endurance meant valuable moments of tactical opportunity were lost due to mechanical hesitation. The logistical planning for any offensive had to be massively adjusted to account for the almost certain 50% loss of operational readiness on the road march alone. An officer's primary concern often shifted from reading the battle map to monitoring the health of his tank's engine and transmission gauges. The constant need for recovery support tied up men and material, preventing them from being used for maintenance on other, more reliable vehicles. This psychological burden of unreliability created a debilitating caution that essentially shackled the Panther, preventing it from ever reaching its full operational potential. The officers were in command of a masterpiece of destruction, but it was a masterpiece that was constantly one gear shift away from becoming an expensive wreck. The Russian season of mud, known as the Rasputitsa, proved to be the single most effective non-human adversary of the heavy German tank designs. Twice a year, the vast, open plains of the Eastern Front dissolved into a kilometers-deep swamp of sticky, black, and relentless mud. This natural phenomenon ruthlessly exposed the fatal flaw in the Panther's complex, weight-distributing interleaved road wheel system. The design, while excellent for ride comfort, created numerous tight crevices between the overlapping wheels where mud would pack solid. Once packed, this viscous soil would act like cement, especially when freezing temperatures set in overnight, completely immobilizing the heavy tank. The 45-ton weight of the Panther, coupled with its tendency to sink deep into the saturated ground, made recovery an almost impossible task. Standard recovery vehicles were often insufficient to pull the mired Panther free, requiring the effort of multiple specialized heavy-duty tractors. Crews were forced to endure hours of back-breaking, exposed labor, attempting to dig their enormous machine free with nothing more than shovels and primitive levers. The sight of Panther crews desperately trying to pull their tank from a mud trap became a common and demoralizing scene across the entire Eastern Front. Countless Panthers were lost not to enemy fire, but to the simple, overwhelming physics of being hopelessly entombed in the Russian soil. The Rasputitsa stripped the Panther of its one true advantage over the heavy Soviet KV and IS series, its superior mobility and speed. Nature itself became the German supply line's most vicious saboteur, turning the technological marvel into a static, helpless casualty of the terrain. This environmental vulnerability was a constant, frustrating betrayal of the officers' trust in their tank's ability to operate anywhere and anytime. The pervasive mechanical failures of the Panther tank rapidly cascaded into a full-blown logistical crisis that strained the already collapsing German war economy. The continuous breakdown rate meant that a disproportionately high number of spare parts, especially final drives and transmissions, were required at all times. Wartime bombing campaigns and the increasing lack of raw materials made the consistent production of these high-tolerance, complex components impossible. Repair depots were overwhelmed, becoming vast tank graveyards where dozens of disabled Panthers sat idle, awaiting replacement parts that were months away from delivery. The necessary field maintenance for a Panther was far more complex than for the older Panzer models, requiring specialized tools and highly trained, scarce mechanics. Instead of routine maintenance, every field repair often turned into a major, multi-day, resource-intensive overhaul of major components. The need to recover the heavy, broken-down Panthers from the front lines placed an immense burden on the German recovery battalions. Recovery of a single immobilized Panther often required an entire recovery platoon and was a highly visible, high-priority target for enemy artillery. This continuous drain on mechanical assets meant that the logistical tail of the army was unable to support the armored fist it was intended to serve. Unit commanders were forced to cannibalize broken tanks for parts, a desperate measure that reduced the overall strength of their regiments even further. The vicious cycle perpetuated itself. The tanks broke down, repair was impossible without parts, and the lack of parts guaranteed more tanks would be abandoned. The operational readiness of the Panther was consistently so low that its mere presence on the roster often represented more a liability than a strength. The German dream of a decisive, technologically superior armored force dissolved into a nightmarish reality of unmanageable breakdown statistics. The over-engineering that gave the Panther its combat edge simultaneously transformed its basic field maintenance into an epic, brutal, and often impossible chore. The complex interleaved road wheels, while excellent on the move, were an absolute disaster when it came to servicing the suspension or replacing an inner road wheel. The process of gaining access to a damaged inner wheel required the removal of multiple outer wheels, turning a simple task into an hours-long, back-breaking ordeal. Replacing the massive, heavy final drive assembly required specialized lifting equipment and was simply not a procedure designed for the mud and freezing conditions of the front. German tank crews, exhausted from combat, were forced to become impromptu field engineers, battling their own machines' complexity in the most hostile environments. The sheer size and weight of the engine and transmission meant that basic engine maintenance was not something that could be performed quickly under a rain of fire. The complexity often led to mistakes during assembly, which only hastened the next inevitable mechanical failure, accelerating the breakdown cycle. Unlike the simple, easily repaired American M for Sherman or Soviet T-34, the Panther demanded factory-level precision and clean workshop conditions for its repairs. The lack of specialized training for many late war mechanics only exacerbated the problem, leading to half measures and temporary fixes that failed quickly. Every required repair was an exposure risk, forcing the crew out of the safety of their armored hull and making them vulnerable to snipers and shell fire. The officers' initial belief in the machine was slowly eroded by the constant, grinding reality of its high maintenance demands and the back-breaking labor involved. The Panther was a tank that always seemed to be fighting its crew as much as it was fighting the enemy, demanding an unsustainable level of time and resources. This constant, demanding chore significantly lowered crew morale and dramatically reduced the actual time the tank spent engaging the enemy. As the German army was pushed onto the defensive and began its inevitable series of operational and strategic retreats, the Panther's fate was sealed by its immobility. A broken-down Panther, in the midst of a rapid withdrawal, instantly became a non-recoverable liability that could not be permitted to fall into enemy hands. Standing orders dictated that any tank that could not be immediately recovered must be destroyed by its crew to deny the Allies access to its advanced technology. Crews were forced to scuttle their multi-ton war machine using explosive charges, often aiming for the engine compartment or the main gun breech. The sight of perfectly good, albeit immobile, Panthers being systematically destroyed by their own men was a painful symbol of the German defeat. These losses were not earned by Allied tankers or anti-tank gunners, but were self-inflicted wounds caused by a lack of operational reliability and poor logistics. Thousands of Panthers were lost this way on the road networks of France, Russia, and Poland, transforming mechanical failure into a strategic-level manpower drain. The men who had trusted the Panther's armor to save them in battle were ultimately betrayed by its transmission, which condemned the tank to self-destruction. The emotional toll of abandoning such a magnificent, powerful weapon was immense for the highly professional and often fanatical German tank crews. They left behind a technological masterpiece, not due to fear or lack of training, but because the machine itself had fundamentally failed their trust. The endless trails of destroyed and abandoned German armor provided irrefutable physical proof of the Axis' inability to sustain complex, over-engineered weapons in total war. These silent, broken hulks became monuments to the fatal flaw of prioritizing offensive capability over the simple, brutal necessity of mechanical endurance. The retreat transformed the Panther from a technological spearhead into a costly, cumbersome, and easily discarded liability. While German officers championed the sheer firepower of the Panther, their Allied counterparts recognized and exploited the strategic advantage of superior reliability. The American M for Sherman and the British Churchill, while individually less potent than the Panther, boasted significantly higher operational readiness rates. Allied tanks were designed with simplicity and ease of field maintenance as core principles, allowing them to be repaired and returned to action quickly. The sheer mass production and rugged dependability of the Sherman meant that Allied units could maintain a continuous, overwhelming presence on the front line. Allied commanders knew they could rely on a greater number of their tanks to arrive at the battle and remain fighting for sustained periods. This strategic advantage allowed them to absorb losses and maintain offensive momentum, something the fragile Panther regiments could never achieve. Allied intelligence, fully aware of the Panther's final drive weakness, planned tactics specifically to stretch the German supply lines and force road marches. They understood that the best way to defeat a Panther was often to simply force it to drive an extra 100 miles or execute an emergency flanking maneuver. The high abandonment rates meant the Allies gained invaluable intelligence from capturing almost intact Panther tanks that had succumbed to mechanical issues. The contrast was stark. One side fielded a complex, temperamental specialist, while the other fielded a rugged, dependable, and ubiquitous generalist. The Allied victory in tank production and deployment was ultimately a victory of logistics and reliability over raw, unproven technical specification. It proved the timeless military lesson that the most effective weapon is not the most powerful, but the one that can be relied upon to fight every single day. The Panther's ever-increasing weight created a vicious, self-perpetuating cycle of mechanical failure that proved impossible to escape. Every upgrade to the gun or addition of thicker armor plates added more tons, further stressing the already critically undersized internal components. The immense 45-ton load generated an excessive amount of torque, which the transmission was constantly struggling to manage without failure. The unique, complex suspension system, while designed to handle the load, ultimately contributed to the maintenance nightmare, increasing downtime exponentially. This weight forced German engineers to create a high-performance, complicated Maybach engine that was itself highly stressed and prone to overheating and premature wear. The massive weight necessitated a wider track, which was beneficial in soft ground but required more complex gearing and more powerful components to turn. This cycle meant that every attempt to improve the tank's combat survivability inevitably worsened its operational reliability. The tank was in a perpetual state of engineering conflict, with every design decision serving to undermine some other critical component. It placed an unsustainable burden on the entire logistics chain, from the recovery assets needed to tow it to the factories needed to produce its heavy parts. The German decision to prioritize protection and firepower at any cost led them down a design path that became logistically and mechanically untenable. Ultimately, the Panther was a victim of its own success, as its impressive combat weight became the single greatest factor in its self-destruction. The burden of its own powerful mass was the silent, internal enemy that truly betrayed the trust of the German officers who commanded it. The Panther tank occupies a paradoxical and enduring place in the history of armored warfare, a testament to the dangers of brilliant, yet flawed, design. Its sloped armor and powerful long-barreled gun immediately influenced post-war tank development, cementing its status as a technological milestone. Yet, this legacy is inextricably linked to the stories of mud, shattered gears, and mass abandonment that plagued its combat service. The German officers who initially saw it as the war-winning solution were ultimately let down by the very system that created its power. The Panther's story serves as a profound military object lesson. Technical supremacy must always be tempered by the practical realities of logistics and endurance. It was a tank that possessed the individual attributes to win any single tank engagement but lacked the operational stamina to win a prolonged campaign. The trust placed in the sheer lethality of its gun was ultimately betrayed by the fragility of its final drive and the complexity of its maintenance. For every awe-inspiring moment of its combat prowess, there were countless hours of frustrating, morale-sapping mechanical breakdown. The Panther represents the quintessential failure of German wartime industry to transition from the meticulous quality of a peacetime economy to the rugged necessity of mass production. It was a spectacular machine that failed to be an effective tool of total war, consistently proving that the fastest gun is useless if the tank cannot reach the battlefield. The true tragedy of the Panther is that its crews were betrayed not by the enemy, but by the relentless, unyielding laws of physics and engineering. Its imposing silhouette in a museum today stands as a solemn reminder that in war, reliability and logistics are the silent, most decisive weapons of all.